What is up everybody, I'm Ritvik Dashura and I'm back with a video and some new learnings. In this video we are going to make our first efficient frontier. Before starting it, I would like to have a small request. If you have not yet subscribed to my YouTube channel, then please hit on the subscribe button and also hit on the bell icon. Also, there's a new feature on my YouTube channel. This is my YouTube channel. After subscribing to my YouTube channel, you can click to this button, which is access to my Google Drive, and this is how I will give direct access to my Google Drive, where I save all of my codes. You can use all those codes for your personal uses. There is no copyright issues. It's free for everyone, but the one and only condition that is required is that you should be the subscriber of my YouTube channel. There's some basic details that I'll be asking here, and the email address that you'll be providing here, that will be given access to my Google Drive. I also have some different buttons like LinkedIn group. This is by clicking on this button, you can join the LinkedIn group where we have some important discussions. You can also like the page, the Facebook page where I put all of my updates. You can also join the WhatsApp group. The discussion has not yet started on this WhatsApp group. I'm waiting for a few more to join this group, but very soon we'll be having very robust discussion on this group as well. You can also follow me on Quora by clicking on this button. I used to post a lot of answers on Quora also. So let's start with our video. Okay, so we will be making our efficient frontier, and these are the formulas that I'll be using in order to make the efficient frontier. These are some basic formulas that I think that you have already learned all these formulas. You already know all these formulas, this is the formula that is used in order to get the weights of a efficient portfolio, which is the Merton model, and it was published in 1974. I'll be using this formula in order to calculate the weights of the efficient portfolio. This is the efficient frontier. For someone who doesn't have any idea about the efficient frontier, it is basically the curve that we get after connecting all the portfolios that have the maximum return for all this particular value of risk, or I would say standard deviation. So any portfolio that lies on the efficient frontier is the portfolio that has the highest expected return on that particular level of risk. The portfolio that lies below efficient frontier, like these one, are feasible but they are not efficient. The portfolio that lies above is even more efficient, but actually it's not feasible. You cannot make a portfolio that lie above efficient frontier. So we'll be making this curve, and then in the end I'll have some task for you, which will be making the capital market line. I am not making the capital market line on this video. I will expect it from you guys. You can post your solution on the description, on the comment box. It's quite easy. I'll help you in the end of this video how to make the capital market line on the Python. So let's start working on like how to make the efficient frontier. These are the steps that I'll be using in order to make the curve. Perfect. So I'll be using some real-time pricing data in order to make this efficient frontier, and we'll be taking some stocks which can be, for example, a few of them will be of technology industry, few of them can be finance industry stocks, some automobile stocks, etc. You can also put your own portfolio stocks in order to make the efficient frontier, but I'll be using some 5-6 tickers in order to make it here. So let's start it. Import pandas data reader dot data as fib. By this time I expect you to know all this libraries by heart, because I use them a lot. Data time as dt. Start date is basically dt dot date time. From 1st of January 2010 to dt dot date time dot now. Then tickers are, for example, Apple. We can take Microsoft. Let's take Google. These are the tech stocks. Let's take some different stocks. Automobile, Ford. One more stock, banking, Morgan Stanley. Okay, so for ticker and tickers, DF is equal to, let's make an empty data frame here, import pandas as PD. PD.data frame. This is an empty data frame. What I'm doing is I'm extracting all the pricing data of all these tickers, and then I'm making a different data frame that will be having just the adjusted close price of all these tickers. So df2 is equal to web.data reader ticker Yahoo start and end. Then df, the heading is, column heading is ticker. df2 adjusted goes. Let me first run it. I think it's done. It will take some time because we are extracting pricing data of 5 different stocks, but let's see if we get the last 5 data for all these stocks. Okay, so we have the last 5 data and the first 5 data. Perfect. So we have the we have the DF data frame, which is the pricing data for all these 5 stocks. Now the next task is to calculate the daily returns. Okay, perfect. So let's make a different data frame here in order to calculate the daily return, which is return 1 is equal to import numpy as np.log. We'll be doing the logarithmic return of daily logarithmic return, so df divided by df.shift, just 1 because it's daily. Perfect. Return 1.tail. Perfect. Return 1.head is this one, and the first data is not a number because of the reason that I explained in the last video. If you have not yet watched the last video, click on this I button and see what is the reason that we have NaN in the first row. Yeah, in the first row. So we have the return data here. Now let's do return 1 dot drop NA in place is equal to true. Return 1 dot head. Perfect. So we have dropped the first NA here. In place is equal to true in order to make it permanent. Okay, so we have our daily return data frame now. What is the average and variance and standard deviation in order to calculate? Yeah, we can do it by doing it like this. So we have all the description of this return 1 data frame, and in this we have mean and standard deviation. I'll be using this to get our mean and variance figures. So dot location. My battery is going down. Let me connect my charger. Perfect. So location, and we need mean and this is how we'll get the ER. And the same, in order to get the standard deviation, we need standard deviation, STD. Let's see if it worked. Perfect, but I think it's better to have the better to have it in the array format. Perfect. Now this is done, this is done, this is done, this is done. The variance, although we don't need it, but still let's calculate it, which is basically square of standard deviation. Perfect. Now, sorry, variance is calculated. Now let's calculate the Var-Covar matrix, which is quite easy. If you like, we already did it in the last video. If you have no idea how to do it, no worries, I'm doing it again. Var-Covar 1 is equal to return 1 dot 𝐲𝐸. That's it. It's quite easy. So we have got our variance-covariance matrix. One thing to note is that this diagonal line is basically the variance. You can see that these are the same, this diagonal, and these numbers are basically, for example, this one is the covariance between MSFT and Apple. This one is the covariance between Apple and Google. These numbers are very low because I took the daily return. You can do this thing for annual or monthly return. It's up to you. So anyways, so we have got our variance covariance matrix. Let me put it here. Now let's make two different portfolios. So what I'm doing here is basically I'll be making two different efficient portfolios, efficient portfolio A and efficient portfolio B, and then I'll consider these two different portfolios as two different assets, and then I'll be changing weights of these two different assets in order to make a third portfolio, which is portfolio C. By having many different weights, we can make the efficient frontier, which will be the portfolio C. Perfect. So let's start it. Efficient portfolio A. I just like put a comment here in order to you to get information about this thing, and I'll be putting this code, by the way, on the Google Drive, and you can take it, you can use it. Okay, so the first portfolio, in the first portfolio, let's use a value of C to be 0. The weight of A is this formula. We'll be using this formula, which is S inverse into ER minus EC divided by sum of everything. There's a proper derivation of this formula. We can do it, but I don't think that there's a need to do it right now. I'm just using this formula. This is basically the Merton model. So inverse of matrix, I always forget how to do inverse of matrix. Okay, so I'll be using this formula, which is basically NP dot ln ALG dot IE and V inside this we need Var-Covar 1 and then matrix multiplication ER minus C, matrix multiplication which is at the rate with ER, perfect, minus C1. Actually we will be making two different portfolios, so perfect. Now copy and P dot sum of everything, perfect. So we have got the weight these weights, we can see that the last two stocks have negative weights. It means that we are shorting them. We are creating the portfolio, the efficient frontier, and in this case, it also consider the stocks to short. If you put a constraint that we don't have any possibility to short any particular stock, then we can do it, but that portfolio will not be the efficient frontier. It will lie below efficient frontier. Perfect. So we have got our first portfolio, the weights of all the stocks for our first portfolio. Let's make a portfolio B with a different value, which is 0.04, which is 4%. Weight B is equal to RC and then C2. And then weight of C2 is like this. In this portfolio, we are just shorting one stock. Anyways, so perfect. Now we need to create a third portfolio, which is portfolio C, using different weights of these two portfolios. Perfect. We have the weights. In the efficient frontier, on the y-axis we have the expected return, and the x-axis we have the standard deviation. In order to calculate the expected return of portfolio C, we should have the expected return of these particular portfolios, which is ERA, which is basically the matrix multiplication of the weights and the expected return. So this multiplied by expected return, which is ER, is perfect. Cool. Now we need to calculate the standard deviation for portfolio C. For this we'll be using this formula, basic formula. This is the formula that we use in order to calculate the portfolio variance. If we have two stocks, here we have two different portfolios and we are considering them as two different assets, and so we'll be using this formula. Anyway, so for this we need to have weights. Okay, perfect. Okay, so what we can do is we can have many different weights for these for these two different portfolios in order to get the efficient frontier. Anyways, so we'll work on weights after some time. Let's see what is this variance of portfolio A, variance of portfolio B, and covariance of these two. So variance of portfolio A is basically this formula, which is weight of A multiplied by Var-Covar multiplied by, this is the matrix multiplication by the way, this transposed, and then for B perfect. Perfecto. Now we have the variance. Now we need to calculate the covariance, which is COVAB. The formula for covariance is this one. It's quite easy to derive these formulas, but I don't see any need to do it right now. Var-Covar at the rate. Now this time I'll be using weight of B, not weight of A. Perfect. So we have the covariance also. Bingo. Now let's see. Let's make a list, or I would say an array of different values of weights for portfolio A and portfolio B. Now how to do it? I'll be using linspace here. So WA, which is the portfolio, weights for portfolio A, it will be np.linspace. I hope I didn't make any mistake here to write it, and it will be changing from say minus 4.5 to 1.5, and say like number of weights is 10. So what I'm doing here is actually I'm going from minus 4.5 to 1.5 by evenly changing it, and this is how we can do it. If we do it 100, it will still go from minus 4.5 to 1.5, but we have 100 different weights that are evenly distributed. Okay, so perfect. Now weight of B is basically 1 minus WA, because weight of A plus weight of B should be 1. So we have the weights now. Now let's calculate first of all, let's calculate the expected return for C, which is basically weight of A, which is an array, multiplied by ERA, which is a number, plus weight of B, which is an array, multiplied by ERB. Perfect, we get the array for ERC. Similarly, we need an array for standard deviation of C, because in efficient frontier we have standard deviation on x-axis. The formula to calculate the standard deviation is this one, basic formula, which is np dot square root, because it's a standard deviation, I'm doing square root of variance, and we can actually calculate standard deviation of these two as well, which is np dot square sqrt of var A, and similarly standard deviation of B is np dot sqrt var B. Standard deviation of portfolio C is basically WA multiplied by standard deviation of A square two times WA WB multiplied by covariance of A and B. I hope I didn't make any mistake here. Perfect, we have got the standard deviation of C as well. Now it's quite easy. We have in the efficient frontier, we have the expected return of portfolio C, which is called the efficient frontiers, and we have the standard deviation, which is the risk. Now it's quite easy, we just need to plot it. Import matplotlib.py plot as plt dot plot. In x-axis we need stdc, and y-axis we need erc. plt dot show, and we have got our first efficient frontier. Perfect. In order to make it better looking, let's change it like this, and we have exactly got it, which is very similar to this one. Bigger. So we are done with our task. No, we are still remaining with the GMVP, which is the global minimum variance portfolio. Basically this portfolio is the portfolio with the minimum, with the lowest value of the risk, which is the standard deviation. It lies here at this tip. Now let me do it here. GMVP, global minimum variance portfolio, is equal to, this is the formula in order to to get the GMVP. Again, there's a derivation of that, and I don't need any I don't see any need of deriving it here. We are just using these formulas in order to plot the graph. I think it's once. Yeah, I would say Var-Covar dot shape once, and then let's see if it worked. Perfect, it worked. Now we have this one unit matrix. This is not this unit matrix. Let me do it here. Unit matrix UM is equal to this one, and in order to make it easy, let's do it like this. UM and then inverse of Var-Covar, which we have already done it here, at the rate this one, and divided by unit matrix at the rate this one at the rate unit matrix dot T. We have got an error here. Matrix dot T. It should be an array. Probably I made some mistake here. So unit matrix is an array, and then inverse of this. Let me check it. Okay, this is an array. So up to here we are right, and then divided by unit matrix let me put a bracket here. Maybe I made a mistake to put a bracket. Perfect. I don't know what was the mistake. Maybe I didn't put the bracket. So anyway, so this is the global minimum variance portfolio. We will plot it on the graph. The expected return for global minimum variance portfolio is basically GMVP matrix multiplication ER, and the variance of global minimum variance portfolio, not variance, standard deviation of global minimum variance portfolio is basically NP dot square root, and then we'll be using this formula, which is this one, GMVP at the rate Var-Covar at the rate GMVP dot T. Perfect. I think it's correct now. So let's plot it here. PLT dot scatter STDG comma ERG. So we have got our global minimum variance portfolio here. Now I am stopping my work here. Now I want something from you. Basically your work is to make the capital market line on this efficient frontier. I'll be posting this code on the Google Drive. You can take it, and then what you need to do is basically it's quite easy. You'll be making the capital market line. How to make it? First of all, what is it? The capital market line is basically the line which is tangent to efficient frontier. It starts from 0, that is free rate coordinate, and then it is tangent to efficient frontier, and the point of tangency is basically the market portfolio, which is this one. We can see it here. Market portfolio is basically the portfolio that lies on the efficient frontier with the highest Sharpe ratio. The formula to calculate the Sharpe ratio is basically RP, which is the portfolio return minus risk-free rate divided by the risk, which is the standard deviation of the portfolio. Now, how to do it on Python? There are many ways to do it, and you can try your own method. Right now, what I'm thinking is what you can do is you can make a different data frame of risk, return, and all the different Sharpe ratios that will be calculated using this formula, this one. And then after that, what you can do is basically, you can get the describe of that particular data frame. For example, you made a data frame called df3, so you can do df3.describe, and you'll get this description, and in that description you have a lot of things like count, minimum, and we also have the maximum. So what you need to do is you need to take maximum Sharpe ratio. What is the value of the maximum Sharpe ratio? Then just take it, save it in a particular variable, and then you can make one more data frame by changing the index of that particular data frame to the Sharpe ratio. So in that, the second data frame will have the index of Sharpe ratio, and then you can just locate that particular maximum Sharpe ratio and get the risk and the return values for that Sharpe ratio. So that risk and return is basically the point, the coordinate of the market portfolio, and then you have two different coordinates, which is the market portfolio and this one, which is 0, risk-free rate. Then you just need to draw a line on Matplotlib. That is quite easy. I would expect some answers for this task. You can write your code on the comment section. You can also approach me if you have some difficulty to do it. This is quite easy, that's why I'm leaving this to you, and the motive of this video was to make the efficient frontier. Anyways, I hope you like this video. This was a quite long video. We have covered 30 minutes, but it was worth it. I'll save this code on the Google Drive. I hope you like this video. In order to stay tuned, please subscribe to my YouTube channel and hit on the bell icon. I'll be making a lot of videos, and with time I'll be putting some more videos on neural network and how we can implement neural network and machine learning into the field of finance. So I hope you like this video. Thank you so much. See ya.